So this fan took 6 years to make. This is Phanteks' new T30 140mm fan, and they're going for not to a competition, but I guess instead of brown and beige, it's gray and gray. So we're gonna actually talk about some of the technical side of this fan. We'll go over there really briefly. This wasn't intended to be part of the intro, but this is a pretty cool demo. So I'm gonna be joined by the CTO a little later in this video. We're gonna talk about some of the specifics of manufacturing challenges and some of the stuff, detail that normally I personally wouldn't have access to just because I don't do the manufacturing. So we'll talk about things like balancing the blades, inserting spacers to maintain the balance across the blade through the manufacturing process, different variants and tolerances and things like that, and going over the fan design. But in addition to the fans today, we are also going to be talking about some of the cases. So we're out here at Computex 2025, which means there's a ton of just new stuff in general. So this is the X2 that we've shown in the past, but it's the Matrix version, which is something that they're playing around with on 2 variants of the cases today, where it's an LED panel. So this is not like a display. It's just it's Matrix LEDs. There's 900 of them on this, so it's a 10 by 90. And in this case, there's 600 of them, so it's a 10 by 60. And then on the software side, over here, basically, you can reconfigure it to show different stuff, which I see someone's typed in Gamer's Nexus here, which is excellent. And one of the things we saw earlier is this is a CPU temperature readout, and my suggestion to Phanteks was you need to put a thermocouple in 12-volt high power connectors and then read that out. And so then you can watch as it starts to melt, and maybe it can switch over to an animation of like the cable on fire or something like that. So that's my advice. For the other cases we'll talk about, so this is the G370A. This is a $60 case with 3 fans in the front. And then that one right there is a Micro-ATX case. We'll talk about that as well. But let's get into the Phanteks booth. Before that, this video is brought to you by the Thermaltake TR100 Portable Mini ITX Case. The TR100 case has a mesh ventilated front panel, heavily perforated side and top panels, and claims to support up to 280mm liquid coolers and large GPUs up to 360mm long and 70mm thick. It even has an optional suitcase with cutouts for the system, a mouse, keyboard, and monitor for transport. The Thermaltake TR100 Mini ITX Case targets portable, smaller form factor PC building while maintaining compatibility for relatively large components. Learn more at the link in the description below. We'll start with the G370A. So this is the budget case, and this has 3 120s on it. So they're going with the 3 120s in the front here. We'll go ahead and pull a couple of other panels. So the glass just secures like it typically does. And then for this side panel, I've already popped it off actually. No ventilation, just a straight steel side panel. And actually Bitwit Kyle, the man behind the curtain.
Thanks, Steve.
Thanks, Kyle. He's our director. He just tells me everything to say and then I say it. So he handed me a script like 5 minutes ago. Thanks, Kyle.
Anytime, Steve.
All right, so we'll keep this case pretty simple. This is a 38% hole porosity on this. So instead of the G400 style bricks pattern, we're in that 50 to 55% porosity range. This closes off a little bit, and the explanation I always get is, it's just circles. Circles, you're gonna have more dead space in between. So it reduces the porosity a little bit. Phanteks says that manufacturing typically will default to something like 25 plus or minus percent for porosity. I think this is similar to what we've tested in the past though. The 3 120s are interesting, where my first question was, why not take this and do that? So that this bottom fan can get a little more exposure over the power supply shroud and force air into the GPU a little better. The top side, you're not going to get a whole lot of benefit other than maybe some VRM thermals, but really the only answer was just clearance for a 360 on the top. So this case, they have shrunken it down as much as they can to where basically this entire top panel, if you put a 360 up there, that's going to be the entire top of the case. So that was the trade-off they made. We'd have to do testing to know if it would really matter, but for the air that's coming in under the shroud, there's not a lot of places for it to go. Some will come out of the cable pass-throughs if they're empty, and otherwise, the rest of it's just going to kind of float through the power supply shroud. So for other features on the case, this technically, it does support SSI EEB, so it supports larger workstations. Now, Phanteks said that looking at kind of the market, apparently a lot of smaller companies are doing workstations in tiny boxes. I'm not too familiar with the workstation market, so the reason they've added SSI EEB was to expand support for that. Now, it does cover the cable pass-throughs here, in that situation, so they've punched out a larger hole up top here to try and help deal with that. It's gonna be, it's a lot of cables to shove through and then route through the back for an SSI EEV board, but I mean, I'm not really gonna be upset about having additional support if it doesn't take away anything, which having a couple holes doesn't. So for the back side of the case, this is a gray motherboard, which I'm only pointing out, not because they spray painted it, but because I was just arguing with MSI that this color is not white. And their new motherboards are this color, and they call them white. So that's gray. But anyway, drive mount, this is not included. That's just to power the fans, and otherwise pretty standard case. It's using the 25 mil thick 3x120s AR or RGB that come with the case. And then there's a couple slots in the top and the back. So let's move on to the next one. All right, so this is a Micro-ATX case. This is the XT M3, and it comes with 3 fans, $70 case. So for the paneling, you can see the shaped punch out here for the fans at the front, then solid on the other side, which there's nothing over there anyway except for the power supply. The top panel I did want to point out, so this is standard, just ventilation. This is closed because it just overlaps with this piece of steel here, so nothing to ventilate there anyway. This is very low sort of ventilation, it's low porosity, but the power supply ends up mounted up in the front on the side, so it's offset from the fans, which is supposed to get out of the way of the fans. Some of these smaller box cases or medium-sized boxes will block the top slot with the power supply if it's rotated that way. So they've shoved it over. The exhaust ends up kicking out here, intakes through the side. The side panel does have punch outs in it, so that's ventilation for the power supply intake, and then the exhaust for it ends up coming out here. Now, power supplies we don't currently test thermals for during our case reviews, but I think I might want to start. We could run a thermocouple to some of the components or something like an APFC FET or something. They are tested in very high heat conditions, typically 50C for standard testing for 80 plus or cybernetics, and that means they can take a lot of abuse. And so my level of concern for this is not nearly as high as if I saw this in front of an intake fan for the rest of the case, but it is something that I was just thinking, oh, maybe we should test some power supply thermals. For the case, should be shipping really in the next month or so. It's 39.5 liters. Phanteks is counting the feet for that, which I actually appreciate because a lot of companies will literally cut corners there to try and get the number smaller. It's one of the instances where smaller number better. There's a huge amount of cable management depth here. They do support BTF for those who care about it. So you've got the cheese grater set of holes through the motherboard tray as a result of it. And then this panel clamps down all the power supply cables. And that's about it for this case. Now the last cases are the Matrix ones. So pricing on these, the X2, the base price right now is a little difficult to keep track of just because of the tariff situation. So it was something like $150 for the non-Matrix X2. Now, I don't know. I have no fucking idea what the prices are of anything anymore. I think it's like 160, 170, something like that. But it has gone up. The Matrix version, basically they're keeping let's do it this way. They're keeping roughly a $30 or so plus or minus offset for the Matrix versions of the cases versus the base model. So that'll be easier to follow. This should end up somewhere around 200, I think. But the interesting thing with this is just that this LED panel wraps. And so it's just large LEDs. There is a fabric cover. So that's on the front here. And then that was just punched out so you can see into the LEDs. You can use the software to reorient the design. And then as far as the software, Phanteks did spend some time saying that they've basically shot for low CPU utilization and a memory utilization. So currently it's 0.3%. I mean, we'd have to actually try and do stuff with it to see if we could run that up. And then as far as the communication, the protocol, so they're using USB, so USB type 2.0 in the motherboard, and then SATA for power, which also allows them to bypass things like a WinRing 0 type of driver situation. And then this is just a flat version of that same panel idea. So that'll cover the stuff with the cases that we care about. That one's supposed to be about $120 or so. And otherwise, let's get over to the fans now and get some discussion on the technicals. All right, so now we're going to talk about some of the technical details on the fans. We've been doing this more, trying to get people from behind the scenes to explain things I might not have access to. So manufacturing is one of them and challenges. And we are joined by Phanteks
CTO. Yeah, I'm Tenzin. Great having you guys. So
yeah.
I work on as a product designer at all of our products at Phanteks.
So how you said one thing to me right before we started shooting this, which is you spent 6 years.
6 years. This one,
on
yeah.
these fans.
And before that was the 120, you know, and a lot of the things we learned for 120s apply to this one. So it's really at least 8 years project for me. You know, I'm really happy to talk about it.
I really want to start with just a topic that's been coming up a lot, which is the blade tip clearance and some of the materials choices, some of the manufacturing challenges. And so, you know, as we've been covering the high-end fans more and more, which is what this is, the thing that keeps coming up is, one is LCP for the expensive, good fans. And then two is blade tip clearance, and they're related. But something you kind of pointed out to me is, you know, well, it's not as simple as just a number for the blade tip clearance. Can you walk us through some of that?
Yeah, that's the thing. It's not, you know, usually things are more complex than just the numbers game. And the blade tip clearance in the premium performance fans is a common theme, right? And everybody tackles it a different way. One of the way is using LCP. That gives you a big boost. And then it's about tolerances, the tooling, how stable can you and reliably can you produce it, right? Because there's a lot of factors like tooling wear and maintenance, and those are big challenges for us.
Why is the maintenance a challenge?
I think with materials like these, like temperatures are higher, the fiber content is higher, so the wear on the machine is much greater, and so everything. If you don't pay attention, it gives you trouble a lot faster. So from a manufacturing point of view, they want to push you with bigger tolerances, right? And we're aiming for tighter tolerances. And then we end up, you know, all those materials and tooling choices end up in this number of, let's say, 0.8, 0.6, 0.9 millimeter tip clearance. And it's a good indication, but it doesn't say everything, right? I think this one we have on our T30 140, we have a tip clearance of 0.9, which maybe somebody else might say, oh, ours is 0.8 is better. But there's more to it, right? We got a tip clearance is along the entire blade edge, right? And it has a leading edge at the tip, at the top of the fan, right? And the trailing edge. And what we do is we have a clearance of 0.9, but it's parallel. And really honestly, the only number that matters is the one at the tip. Because that's where the air, you know, it gets flung to the edge and it wants to escape at the front, at the top end. So really the tip clearance is the one that should matter.
I mean, you're talking about, I guess there's tip and tail clearance, sort of from the frame. And so you're saying the up here, so it's the leading edge of the blade. You're just trying to trap the air and force it through.
And that's the one we care most about. And that one is 0.9.
So in manufacturing, I mean, does maintaining shape, so like these are really, you know, specifically made shapes. Is that a challenge? And as you use the machine and the tooling, does it wear down the tool?
Everything starts to wear down, and then the variation in each unit you make starts to increase. So the material, the steel surface in the tooling starts to erode, gets a little bit rougher, so it sticks a little bit more, and so everything starts to deviate a little bit more, which, you know, a little bit you can't prevent it totally, but you have to keep it in check because each of our fans is individually balanced. We got two balancing rings, top and bottom, so you can imagine if the tolerances are increasing, like the weight distribution or it's slightly bent a little bit more and more, you start to have to do more and more balancing, and it gets out of control pretty quickly.
What does tool maintenance look like? What does that actually mean?
Yeah, it's like let's say polishing the surfaces again. That's like a number one thing. Doing repairs, and maybe you can have a few, let's say, light maintenance rounds before you need like a big overhaul of the machining. And it's also, you know, it's logistically it's a big challenge because you want to place an order, but say, hey, it's in maintenance right now. And we even had one that just think about it with our 120, you know, it had to go for maintenance, and it was during COVID time. So it got stuck. The actual truck with our tooling on it that was finished maintaining got stuck into quarantine just outside of Shanghai during maintenance, and then we were out of stock for a while.
Make fans.
Yeah. So it's like you don't want to have that many maintenance runs.
So tooling for cases, I know, can be hundreds of thousands of dollars.
Yeah, these are very expensive. Like in general, injection molding tooling is a lot more expensive because there's a lot of cooling involved, for example. So they are way more complex. And then if you go like glass fiber filled and then LCP, it's way more expensive.
What does the glass
Yeah.
fiber percentage actually do? What is it contributing?
It's just the rigidity, especially with higher temperatures. It doesn't affect glass fiber, right?
Okay.
So it really keeps keeps the dimensional stability stable. Yeah.
There is another thing you pointed out, which was on the numbers that end up on every fan company's box. So we've talked about this in the past on GN, but just how flow and pressure on boxes on specs they're represented in the easiest way to test, which is normally like open flow, for example.
Yeah.
But you had some thoughts on it, so what do you want to point out?
Yeah, it's similar to the gap, right? The tip clearance it changes into a numbers game, and I would love to tell people more, but it's tricky to convey that message, right? So the standard way is the maximum numbers are listed, right? What is the maximum CFM it could do, but that would be at 0 pressure, and what is the maximum pressure it could do at 0 flow? And I understand, everybody knows it's not standardized. So they know, I can't compare this number from this brand to that brand. But you would think, even on our webpage, on our T30 webpage, you could compare our numbers. And even there is a challenge because they are tested the same way. That's true. But if you look at our T30 120 pressure, maximum pressure, it will be 7.11, I believe. Like at 3,000 RPM, right? It's 7.11.
Yeah.
And this one is 5.41.
Okay.
Right. So even on our product page, I can totally understand people would think like, that's weird. Why is the bigger one, the more premium one, right? The more expensive one.
Why is it like
Why is the
worse?
number smaller,
Right.
right? Big number better,
Yeah.
right?
Yeah.
But if you would put it to test, no, the T30 140 is better in that sense. If you have the bigger
So
radiator,
what isn't
it is
told?
better.
What's not getting told in that number?
Yeah, I think really it's a synthetic benchmark, right? If you have to find a comparison to it, and really, and it's represented by this curve, right? It's the two ends of the curve. You as a user or your system is never at the ends. It's somewhere in the middle, and on radiators you're at the upper half, right? And maybe air cooler you're at the lower half. That's where you want to be, and that's really the number. I would like to tell people. And then you get into the standardization game. It's very difficult. Like what was the specific heat sink and all that kind of stuff. Yeah.
Well, and so on heat sinks, you were talking about how one of the factors that's maybe not represented in these numbers is the direction of the flow.
Yeah.
So where does the air go once?
Yeah. So that's that really comes down to our T30 140 development, where we kind of 140 millimeter fans are great at cooling on an air cooler. They're great. So when you're developing, you're making amazing improvements, right? It feels great, and you keep chasing that bigger numbers. Yes, even better, even better. And then we found out like, hey, our radiator performance, especially with AIOs, like the high density fins, the thinner ones usually, it was still, being left behind. And we keep testing, and actually, to be honest, every 140 millimeter fan on that application is kind of falling behind. It's not the increase you would expect from going from a 120 to the 140 one. It's pretty close. Like our T30 120 used to be really close to our 140 that we took all the way to tooling, all the way to the finish line, and then it just didn't feel right? That's not what you would expect. So we went back and we really figured out, you got pressure, you got airflow, but the air has a direction. And with an air cooler, you got the flat tubes, you got the folded fins, and it's like blowing at an angle and trying to get it through a straw.
Yeah.
Right, that's what you're trying to do. And then we started back from scratch, and we really wanted to guide the air to that straw, really, that's inside every radiator. And that's really what we aimed for, and it means you also have to give up on something else, right? You can't have everything. And we really focus on the hard part for a 140 millimeter fan.
Right. What about, so we'll just kind of quickly go through some of this stuff.
Yeah.
So for more product level detail, I guess the 140 version of the T30 is pricing for supposed to be $40.
Yeah,
is that right?
it's
For
40
one.
for a single, and then 115 for triple pack. Yeah.
And then you're doing LCP with glass fiber reinforcement, and the LCP is for the whole. It's for the frame and
fan.
the blade.
Yeah, because the frame, it needs that rigidity for that tip clearance, right? So it's really important.
What are you showing here? What's
Yeah, so every I love to show, you know, because I don't expect people to do this. So please don't. So let me show you. You can see the motor. That's the part where we're so happy to work with Sunan, because Sunan they've been making so many fans for a lot harsher conditions. You know, running 10,000 RPM 24/7.
Sunan made some of the early maglev fans.
Yeah. So this is also a maglev fan, and this is like the so many iteration, which they call the Vitalii bearing, and we can apply all those years of experience that they have. And from those much harsher conditions, so in the motor. So you can see that is the steel plate at the bottom that gives you that maglev feature. You got the 6-pole 3-phase motor, so it's a lot smoother at low RPM. And they even tweaked for us the alloy they used, because they run their fans, let's say, at a high level and then a panic mode, right? Safety feature, but always high. But we expect users generally to mostly run low RPM. So you can tweak the bearing material, so it's more, let's say, tuned towards the lower RPM range in terms of sound.
What does it mean to tweak it? Like, what's changing?
Yeah, well, it's a alloy, so you can tweak like how much zinc is in there or how much copper, and I believe it's a little bit less zinc, a little bit more copper, and so it kind of lubricates a little bit more. It sounds a little bit smoother at low RPM, like 600 RPM. We kind of faintly could hear something like, "Hey, is it rubbing like a piece of paper, maybe?" And that was because of the bearing material at that time was tuned towards like 5,000 RPM.
Right.
Yeah. So that's been great working with Sunan on that part. And here you can see the back of the blade, the inside that you would normally never see, and you can see at the well, here's the bottom, but it's the top side of the hub, of course. You can see a ring with spaces, and then you see one at the bottom. And then this particular one, it has 3 points filled. Okay. Right, with a black material.
And that's for weight balancing?
You weight balance. So each individual one, and this is, I honestly, you know, I went at our office, so I popped off a whole lot of them, some at 0. Golden sample, I guess. Yeah. And then some were the highest I could find, realistically, was 5. So this one 3 is like the average, let's say. And
so is that put in after manufacturing to basically balance for tolerances?
Yeah,
yeah. I didn't know that.
And that makes a big difference also on durability. The more stable it is, the less strain is there on the bearing.
And then they're just like plastic spacers, or are they the same LCP?
It's like a putty material.
Okay.
Yeah,
got it.
Yeah, and then that hardens and adheres to the.
Cool. How do they check for the weight distribution?
Yeah, they have like so many, you know, amazing machines, like all expensive. They put it on and it can measure it, but it can measure it in 3D. Okay. That's why, because some brands, you know, okay, they do some balancing, but they do it on one level. But there might be, you know, maybe it's pushing the axis in an angle, and the tip gets a little bit more stress, and so you need, really, if you want to do it properly, you need like 3D, both top and the bottom balancing. Okay, which you do here. Cool. Yeah.
Awesome. And then we'll keep this to like a minute or two. But what are anything here you're showing that you want to get into before I jump back to the rest of the products?
I think this picture maybe is great for people. Okay. What LCP? Because LCP it's almost becoming a common thing for the most premium fans. Yes, it's not unique to one brand using it. I think this kind of explains to people what makes LCP great. Is normal plastic is like a ball of spaghetti. Yeah. Right. Yeah. And then metals are perfectly aligned crystals. And then the LCP kind of is like I call it like an uncooked pack of spaghetti. Okay. Right? It's spaghetti, but aligned.
We need to continue the food theme somehow to this, because you've got 2 food themes going.
Yeah, those are like crispy potatoes put together. Yeah,
okay, excellent.
We've completed roasted potatoes.
So we've completed the metaphor.
Yeah. And you can see that crystalline structure on our LCP material.
Okay,
that's what it is. Really.
Got it.
Yeah. So uncooked spaghetti.
Right. Yes. Should add that to the next April Fool's video you guys do. You can make an uncooked spaghetti fan.
Yeah, that would be great.
All right, we'll jump back to the rest of the video, and thank you for joining me.
Thank you so much. Thank you.
So that'll cover our Phanteks suite coverage at Computex 2025. We have a ton of other booths we're looking at. So we did videos already on Height, Montech, We've got a couple others coming up as well, Lian Lee, stuff like that. Check them out. We're posting multiple videos per day while we're at the show, doing news gathering at everyone's booths and suites. And it's going to be like 3 or 4 a day, so you might need to check in YouTube manually just in case it doesn't send them to you all. They have water cooling stuff as well. We're not going to talk about this today. There's plenty of other media here doing coverage, so maybe check out Kyle's video for some of that because he's here as well. And thank you for watching. Subscribe for more. Go to store.gamersnexus.net. Support us directly or patreon.com/gamersnexus. And we'll see you all next time.